Hey guys, welcome to Unit 7. We're going to start with just like a combination of lessons 1 and 2. And in this lesson, we're going to focus on the law of sines. So what's really useful about the law of sines is it deals with non-right triangles. So think about everything that we've talked about for the most part in trig has dealt with some form of a right triangle, whether it be like on a coordinate plane or like angle of elevation or angle of depression. Like we have been in the realm of right triangles. And so today we're going to go away from that. So it has a really useful formula. It's really easy to use. Sine of A, sine of B over B, and then sine of C over C. So think about what you know about solving right triangles. So it's like the angle over the opposite side length, angle over the opposite side length. So the math for the most part is really easy because you're just going to set it up in basic proportions to help you solve it. And we're going to go ahead and get started. I think I want to come back to this one. Let's start out with a really basic one. So this is like that second example in your notes. So let's kind of jump there. So I'm going to start off with the formula. And again, like if you don't have A, B, and C for your angles, change it to whatever you need. But let's start off with the formula. And let's go ahead and draw our triangle. I have no idea why I printed off like this. It's just triangle ABC. So I'm just going to draw this generic triangle. I'm going to call this ABC. Then I'm going to fill in what I have or what I know. So again, like go back to what we know about solving triangles that we did like in a few units ago. So I know that this is like this is little a, this is little b. So let's kind of think about what we're missing. So we are missing, let's see, angle C. We need to fill that in. We're missing side length A and we're missing side length B. So we're looking for those three things when we're going through this. So from here, what I'm going to do is I'm trying to figure out the color I want. From here, I want to kind of think about a game plan. Well, still, even if we don't have a right triangle, I know that all three of these angles add up to 180. So let's go ahead and figure out what angle C is. So go ahead and do that. So you should have the angle C equals 88 degrees because 88 plus 42 plus 50 should give you 180. Okay, now we're going to apply, now that we have that, let's apply it to this formula. So I think we have everything I need. So the sine of A, so I'm going to say the sine of 50 over A, I don't know that one. And then the sine of angle B, which is 42, over B, don't know that one either. And then sine of C, so we just found out that angle C is 88 degrees, and we do know the side length of C, which is 10. So what we're going to do is, this is kind of our go-to guy right here, because we have like both the top and the bottom of that. So we're going to use that to solve for A and B. So I'm just going to start with B just because it's right next to it. So I'm going to set this up as a proportion. You could definitely have started with A too. It doesn't matter. So you are just going to cross multiply and divide. So I have 10 sine of 42 equals sine of 88 times B. So I'm just going to divide by the sine of 88. Oops. And type that whole thing in my calculator. So all of this good stuff in my calculator. And if you did it correctly, you should get that B equals about 6.7. And so I'm going to add that to my list that we found. I also found angle C. Okay, so the last thing that we need is angle A. So I'm just going to use this one and this one. You could totally use this one. It's just since it's since B was like a yucky decimal, it's best to like use what you've been given. So I'm going to set up a proportion with those two. So sine of 50 over A equals sine of 88 over 10. So go ahead and cross multiply again, use the same process and see what you come up with. Okay, so when you did that, you should have come up with A equals about 7.7. So let me just set this up really quickly. It should have been 10 sine of 50 divided by sine of 88 equals A once you did that cross multiplication. So we have everything that was missing and we're done with solving our triangle. Again, think about what you're doing. You are not solving right triangles anymore. You're just solving any random triangle. Okay, so now let's go back up to this first example. So go ahead and fill in, I'm going to push pause. Go ahead and fill in the triangle, what you have and what you need, and then set up your law of sines formula. Okay, so this is the stuff that you should have so far. I didn't put what I was looking for. So I'm looking for angle T, I'm looking for angle R, and I'm looking for little t. So those are the three things that I'm looking for. So here's my formula and I applied what I had to my formula. So this guy over here, he's not going to give me anything. So I'm going to start with this proportion. So I'm going to say the sine of r over 30 equals the sine of 40 degrees over 20. So I can totally solve for r here. So go ahead and do that. We're going to talk about how this is really a sneaky snake one, and you probably won't even see it. So go ahead and try for that. Okay, so I went through the process here of just basic algebra. And then I ended up with the sine of r equals this. So I applied the sine inverse function, and I bet that most of you got this. This is not incorrect, it's just not complete. So think about everything that we've talked about in the past. When you apply this, you have to think about, okay, well, in which quadrants are sine positive and which quadrants are they negative? So it's positive in quadrants 1 and quadrants 2. And what is interesting about sine is it's the only function that both measurements in quadrant 1 and quadrant 2 for those angles will actually fit within a triangle. So we need to apply both of those. So in quadrant 1, totally like 74.62 is our degree, but we also need to account for the angle that shows up in quadrant 2. So I'm going to take 180 minus my reference angle in quadrant 1, and I get 105.38. I don't know why I rounded off to 2 decimal places. It doesn't matter where you round off. So I have to account for both of those angles. So this isn't really like every other time we solve for a triangle, we're like, okay, well, t equals this, and r equals this, and little t equals this. Like r actually has two values, which is going to come into play in like two different circumstances. So I'm going to have like two different sets of answers. So let's go with case 1. And I'm going to assume that angle R is 74.62 degrees. So if I do that and let's go back up here to our triangle. If I add this angle and this angle together, it's going to give me that missing angle if I subtract it from 180. So we're just going to like use the property of triangles to know that angle T ends up being 65.38 degrees. So again, like that's nothing new. I'm just subtracting from 180. Okay, so then I need to come back up here and apply the law of sines formula. So I'm going to say the sine of 40 degrees over 20. So that's the one that we were given right there, equals the sine of r, which we're going to call it 65.38 degrees over t. So in this case, I can go ahead and solve for that t. So we're going to cross multiply and divide, And so we're going to get T equals about 28.29 or 28.3. Okay, so let's go back. Did we answer everything? Do we have angle T, angle R, and side length T? So let's see. We have angle R, angle T, and side length T. So we're good on that one. We have everything that we need. Okay, so let's go to case 2. So I'm going to say, no, angle R is not 74.64 degrees. It's 105.38 degrees. So do you see like both possibilities are totally acceptable. So now what I have to do is now I think that this angle is 105 degrees. So I have to like add these two together and then subtract from 180 to get that missing angle T. So that gives me angle T is 34.62 degrees. So I have angle R, I have angle T, and so now I'm looking for side length T. So I'm going to set it up the same way. I'm just using a different value for R. So I'm going to say the sine of 34.62 degrees, which is that angle T now. Sorry, that looks hideous. Over T. And so again, I'm going to cross multiply and solve for T. And when you do that, if you do it correctly, you should get 17.68. So I have angle R, angle T, and side length T there. Okay, so I'm going to give you one more case. So we've done a case of just like one solution. We've done a case of two solutions, and this is called, where is it? So like this, when you have two solutions, this is also called the ambiguous case. So you'll see that sometimes, like the ambiguous case of law of sines. That's what that's referring to. In the last case, it actually got separated here, but there's actually a case where you get no solution. So let's kind of set this up. So we have this triangle. Again, I have no idea why it's printing it off like that. So triangle ABC, and I'm just going to fill in what they give us. So this is 20, 35, and 42. So I'm going to use the law of sines to get a proportion ready and start solving this. Oops. So again, this one's not going to help me at all. So I'm going to go over to this one. So I'm going to use this to solve for B. So I'm going to cross multiply. So 35 times the sine of 42 divided by 20 equals the sine of B. Okay, well, when you type this in your calculator, you're going to get over 1. So I can't have the sine of B be more than 1. So in this case, it's too big, so we have no solution. Okay, so those are the 3 cases that you'll see with the law of sines. I just want to talk about one more thing, and it's super easy. It's the area of a triangle. So when I think of the area of a triangle, when I'm doing stuff like this, these formulas do not go through my mind. This goes through my mind. So like half a side of included angle, or sine of included angle. Like, so I think that makes more sense. So I'm going to set up my triangle, and I'll show you. Okay, so I'm going to set this up. So half of side, sine of included angle. Like that, in my mind, that's how I think of this. So it's going to be set up like this when you're finding this area. So this is a total calculator problem. So when you type it in, you're going to get about 43.1 square feet. And that is it.